All right, so we're gonna start and just work our way through the entire review for your test that you should have worked on Thursday. So questions 1, 2, and 3 just say solve by factoring. Make sure when you factor, I'm asking you to use your asterisks. You have to make sure you have 0 on one side before you can begin. So question number 1, we do have 0 on one side, so we are going to just use our asterisks. Remember, A is 1, B is -8, and C in this case is +12. So when I fill out my asterisks, A goes top left and top right, so we have 1 here and 1 here. B goes in the bottom middle, so -8 in the bottom middle. And in the top middle, 1 times 12, which is just 12. So once I fill this out, I'm looking for two numbers that multiply to give me the top, but add to give me the bottom. So I'm looking for two numbers that multiply to give me 12, but add to give me -8. Yep, -2 and -6. When I look at my two fractions here, since there's ones on top, I know I can't reduce them, so I'm going to add my variables to the top. And then I'm going to write my two factors from those fractions. So 1x minus 6, or just x minus 6, and 1x minus 2. Again, x and 1x are exactly the same. So there's my two factors. We know if we have two factors that multiply together to give me 0, that one of them must equal 0. So either x minus 6 equals 0 or x minus 2 equals 0. And then we're just going to solve for our x's. So x equals 6 when you add 6 to both sides, and x equals 2 because you would add 2 to both sides on that one. So my two answers to question number 1, 2, and 6. Looking at question 2, the first thing you must do for question number 2 is get 0 on one side. We want to move everything from the right side to the left side. So we're going to add 4x and add 7. So we're going to add 4x and add 7. So there's my new equation. This new equation has 0 on one side, so I can go ahead and put it into my asterisks. 1 goes in the top left and top right. B goes in the bottom middle. Those actually all happen to be 1s. And then for the top middle, I'm going to take A times C. So 1 times -30 is -30. Then I'm looking for two numbers that multiply to give me -30, but add to give me +1. Yep, 6 and -5. So 6 times -5 is -30, and 6 minus 5 gives us that 1. So now looking at my two fractions, neither one reduces because they both have 1s on top. I'm going to add my x's and go write my factors. So x plus 6 because it's a +6. And x minus 5 because it's a -5. Again, using that zero product property, I know that these two factors, my two sets of parentheses, are being multiplied together to equal 0. So I can set both terms, or both factors, equal to 0 to figure out my two solutions. So x equals -6 and x equals 5. Questions or concerns on the first two? So you can anticipate your first two questions on your test going to be just like this. The first one's going to be set equal to 0. The second one, you're going to have to move some terms to get it set equal to 0. Moving down to question 3, again, we're solving using factoring Again, not set equal to 0, so we're going to have to move the 15. So I'm going to subtract 15 from both sides. When I write the left side down, I want to make sure that I'm writing in descending order or standard form, always starting with the x squared, then the x terms, and then your constant. So now that I'm in standard form, set equal to 0, I'm going to fill out my asterisks. A goes in the top left and top right. B goes in the bottom middle. Be careful, for the top middle, you're going to take 6 times negative 15. So biggest mistake I see on this problem is people write negative 15 and they don't multiply by the 6. So we're going to take 6 times negative 15, which gives you negative 90. So now you're looking for two numbers that multiply to give you negative 90, but add to give you negative 13. Yep, negative 18 and positive 5. So this time I have 6's on top, so I know one of my two sides or fractions over here will reduce. So I can reduce the 6 and the negative 18. I can divide them both by 6. 6 divided by 6 is 1. Negative 18 divided by 6 is negative 3. So then I'm adding my x's up top, and those are my two factors. So x minus 3 and 6x plus 5 still equals 0. So now we're going to set both these factors equal to 0. So x minus 3 equals 0 and 6x plus 5 equals 0. Solve for x. The first one, x equals 3. The second one's a little bit more challenging because there's two steps. So subtract 5 from both sides to get 6x equals negative 5. Beside it, divide it. So divide both sides by 6. And x equals negative 5/6. And again, my suggestion would be to just leave it as negative 5/6. You don't have to convert it to a decimal for me. Questions on this one? So this one's definitely the harder of the first three. All right, moving to question number 4, solve this equation using the quadratic formula. The quadratic formula is on your reference sheet that I'll give you with your test, but you've got to know how to use it. So first thing you've got to do before you can use the quadratic formula is get 0 on one side. So add 4x and add 3. So when I add the 4x and I add the 3, that gives me 3x squared plus 4x minus 4. And then my instructions say I've got to use the quadratic formula. So quick review of the quadratic formula. So there's my quadratic formula. Remember, a is the number in front of x squared, b is the number in front of x, and c is the constant. So a is 3, b is 4, and c is negative 4. So when I want the opposite of b, the opposite of positive 4 is negative 4, plus or minus, then my square root. Underneath my square root, I need b squared. So 4 squared minus 4 times a, which is 3, times c, which is negative 4, all divided by 2 times a, which is 3. So then I'm going to type this portion into my calculator all at once to simplify. Which gives me 64, so -4 plus or minus the square root of 64, all being divided by 6. Make sure you've got your fraction bar underneath all of this. It doesn't just go underneath the -4, and it doesn't just go underneath the square root of 64. It's got to go all the way across. Do we know the square root of 64? Yeah. So we're going to go up here. So -4 plus or minus 8 divided by 6. Since we know the square root of 64 is 8, this is where we get to break this apart into two pieces. We're going to break it apart with -4 plus 8 divided by 6 and -4 minus 8 divided by 6. We're just breaking apart this plus or minus sign into two separate problems. Nothing else changes but that sign. The plus sign goes to one, the minus sign goes to the other. And then we're going to simplify both of these individually. So -4 plus 8 is 4 divided by 6, which reduces to 2/3. There's one answer. If I take -4 minus 8, I get -12 divided by 6, just gives you -2. So my two answers, 2/3 and -2. Again, I would just leave 2/3 as a fraction. No need to convert it to a decimal. Questions on this one? Question 5, the trickiest question on your test, I think. So they're telling you the area of a rectangle is 135 feet squared. Find the dimensions of the rectangle if we know that one side is 12 feet longer than 3 times the other side. I don't care about your complete sentence. I gave you, I believe, a diagram with your rectangle. We're going to say one side's X, and then we know the other side is 12 feet longer than 3 times that other side. So 3 times the other side plus 12. If I tell you something is 12 feet longer, you're just going to add 12 to whatever you were given. So we're just adding 12 to the 3x. And then we know that the area is 135. We know to find the area of a rectangle, you take length times width. So we're going to take the length times the width and set it equal to our area, which is 135. Then we just want to simplify this by getting rid of our parentheses. So we're going to distribute. So 3x squared plus 12x equals 135. We want to get this into standard form so we can factor it. So we want to subtract 135. When I look at this, there's some awful big numbers if I would put this in my asterisks. I do notice that all of these numbers are divisible by 3. Keep in mind your shortcut to figure out if 135 is divisible by 3. If I take 1 plus 3 plus 5, it gives me 9. 9 is divisible by 3, so 135 has to be divisible by 3. And we already know that 12 and 3 are divisible by 3. Oops. So we're just going to divide all 3 terms on the left side and the term on the right by 3 to simplify. So that gives me x squared plus 4x minus 45 equals 0. That's what we're going to use in our asterisks. So in our asterisks, we're going to have 1, 1, 4 in the bottom middle, -45 in the top middle. And then we're looking for two numbers that multiply to give us negative 45, but add to give us 4. So 9 times negative 5 is negative 45. 9 minus 5 gives us 4. So our two factors are going to be x plus 9 and x minus 5. Once we get here, we're just going to set our two factors equal to 0. So x plus 9 equals 0, x minus 5 equals 0. So x equals negative 9 and x equals 5. But think back to what x represented in our diagram. So x represented the width of our rectangle. Is it possible to have a width that's negative 9? If I tell you to measure something and you tell me that the length of it's negative 9, I'm going to look at you like you're crazy. So we know that this is our width. But now we've got to go back and find the length. Well, the length equals 3x plus 12. So to figure out what the actual length is, if we know that x is 5, we're going to take 3 times 5 plus 12. Well, 3 times 5 is 15. 15 plus 12 is 27. So the length must be 27. Again, you don't have to write your answer in a complete sentence. I just want to see that you found the width and then use that to find the length. Questions or concerns on this one? Definitely the trickiest problem, I think, on the test. If you need help setting it up, just let me know, and I'll help you draw your diagram. Good. All right, number 6, we're going to answer part A, B, and C about 3x squared minus 3x plus 6 equals 0. I'm going to scroll as much as I can so that I can fit everything on one screen. All right, I think that'll work. So part A asks us to find the value of the discriminant. Remember that we had the equation 3x squared minus 3x plus 6 equals 0. For part A, we're asked to find the discriminant. Your discriminant is just b squared minus 4ac. Again, that's underneath the square root in your quadratic formula. So negative 3 squared minus 4 times 3 times 6. Make sure that negative 3 that's being squared is put into parentheses. If you don't put it in parentheses, you'll get the wrong answer. When you type that all in your calculator, you should get an answer of negative 63. That's your answer for part A. So your discriminant equals negative 63. Since that number is negative, it's two imaginary solutions. So remember, negative numbers give you imaginary solutions, positive numbers give you real solutions, and then 0 gives you one real solution. This answer down here is impossible. You can never have one imaginary number. They always come in pairs. So you'll always have an even number of imaginaries. The letter D is just on there to trick you. Don't let it trick you. So solve using our quadratic formula. Remember our quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So when I fill this in, the opposite of negative 3 is positive 3. When I fill in b squared minus 4ac, negative 3 squared minus 4 times 3 times 6, all divided by 2 times 3. As always, we're going to type this portion into our calculator. what should we get underneath that? Negative 63. You know that if this number does not match this number, there's something wrong. You should get the same thing underneath your square root both times for the discriminant and when you use your quadratic formula. Divided by 6. This time 63 is not a perfect square, so we're going to take the square root of 63 and we're going to break it up into two numbers that multiply to give us 63, but one of them should be a perfect square. 9 and 7, perfect. So the square root of 9 times the square root of 7 is 63. Well, the square root of 63. We know that the square root of 9 is 3, so 3 square root 7 is what, whoops, I forgot my negative. This simplifies to. So since it's negative 63, we're going to pull out an I. So 9 becomes the 3. The I is from the negative that I forgot. So going back to, I'm going to go over here. 3i square root 7 all divided by 6. There's one last thing you need to do. Yep, so we look at our heart. Again, that 7 is protected by the square root. We can't touch it. So we're going to just reduce these three numbers. 3, 3, and 6 are all divisible by 3. So 1 plus or minus 1i square root 7 divided by 2. The 1 in front of the I is not necessary. Final answer. So this question altogether is worth 5 points. 1 for part A, 1 for part B, and then 3 points for part C. On the next page, if b squared minus 4ac, that's the formula for your discriminant. So really I'm saying if your discriminant equals 0, then what are the number and type of solutions that you would get? So if your discriminant equals 0, you would have one real solution. Again, you can never have one imaginary, so you can automatically mark off C. 2 imaginary happen when your discriminant's positive. Negative, whoops, negative. 2 real happen when your discriminant is positive. So imaginary is negative, real, 2 real is positive, 1 real is 0. So you'll have one of those 3 scenarios for question number 7 on your test. Make sure you read it. Don't just assume that the answer is the same as it is on the pretest. Happens. All right, question number 8 is worth 6 points because there are 6 parts. So question or letter A says, what is the vertex? The vertex is either the ordered pair of the hill or the valley of your parabola. So in this case, it's the valley because it's all the way down here at the bottom. It's either the lowest point or the highest point. So that ordered pair is -2, -2. Your axis of symmetry is always x equals, and then you just have to bring down the x coordinate of your vertex. So x equals -2. There's another point. What's your y-intercept? Notice that's singular. Go to your y-axis and find where the parabola crosses your y-axis. Happens to be this point right here. That is 0, 6. So another ordered pair, 0, 6. Technically, you could tell me that y equals 6, and that would be okay because that would be your y-intercept. Is that what you had? That's okay. I saw you erasing, so I assume that's what you did. What are your x-intercepts? Notice this one's plural, so we're going to have more than one. So if I go to my x-axis, it's crossing at 2 points here and here. So those 2 points, -3, 0, and -1, 0. If you have x equals -3, x equals -1, that's again okay. I'm not going to count off for that, I promise. Question letter E, what is the domain? Remember, for every single parabola, the domain is all real numbers. You can write it out, or you can write the symbol for all real numbers, a capital R with an extra line through. I will tell you, question 8, part E on your test, the answer is all real numbers. Because it's going to ask you, it's going to have a different graph, and it's going to ask you what the domain is. The answer will be all real numbers. What is the range? The range talks about the y values. We know that the y value has something to do with this y value for your vertex, but you have to decide if it's y is greater than or equal to, or y is less than or equal to that number. So we have to decide which one of these two is correct. So we want to know if all the y values of our graph are above this point or below it. So they're all above, so y is greater than or equal to -2, not less than or equal. So again, the y value of your vertex is the number you use there. The only thing you really get to decide if it is greater than or equal to, or less than or equal to. If it opens up, it's greater than or equal to. If it opens down, it's less than or equal to, because that's where your graph goes. Questions on this one? Worth, again, 6 points. We didn't really have to do any work. We just had to look at the graph and know the different parts of it. And then I told you the answer to letter E. It'll be the same on your test. Question number 9, another fairly easy question. If you recognize this is in vertex form is on your reference sheet. Vertex form looks like this. Again, it's on that reference sheet. The thing you have to remember is your vertex is h comma k. But when you take the h out of the parentheses, because there's this negative sign there, it's got to change sign. So really in this question, the negative stays there and all you get to take out is the 5. K stays the same because it's positive, so it's going to be 5 comma -1, which is letter D. Really, you could do this problem and not write anything down. So I can look at that and tell you that the vertex is 5 comma -1. Again, you've got to change the sign of what comes out of the parentheses. The number out at the end stays the same. So that's where 2 points. You're either getting both 2 points or you're not. So you're either getting it right or you're not. Hopefully everybody gets it correct though. Moving to question number 10, we're going to start some graphing of quadratic equations. You just have 2 to graph. One of them will be in vertex form. So question 10 is in vertex form. And then question 11 is in standard form. So for question 10, since this is in vertex form, part A asks us if the parabola opens up or opens down. So we're always looking at this first number to determine whether it opens up or opens down. Technically, that's A. If A is positive, it opens up. If A is negative, it opens down. Well, in this case, A is -2, so it's going to open down. What is the vertex? So to find the vertex, if I'm in vertex form, I want the opposite of the inside. So I want the opposite of +1, so I want -1. And then the number out of the end stays the same, so -1 comma +1. So if I graph my vertex, -1 comma +1 looks just like that. So start at the origin, go left 1, and then up 1. Then I ask for my axis of symmetry. Your axis of symmetry is x equals, bring down the x coordinate of your vertex, so -1. So that's our imaginary line that we can reflect over when we graph this. Notice my instructions say answer parts A through C and graph. Some people try to just answer parts A through C and don't graph. So to figure out the rest of my graph, remember my graph should have 5 points on it if all possible. I'm going to make an XY chart or a table. And I'm going to pick two x values either to the left or to the right of -1. So I would use 0 and +1. So if I plug in 0 to my original equation, I should get -1. If I plug in 1 to my original equation, I get -7. And again, I can do that just in my calculator, making sure I'm using parentheses when necessary. So then I'm going to graph those 2 points. 0, -1 is right here, and 1, -7 down here. And then I get to reflect them. So if I reflect this point right here, so currently I'm 1 to the right of my axis of symmetry, so I'm going 1 to the left, and that's going to be my reflected point. Then I'm going to do the same thing with 1, -7, so I'm 2 to the right of my axis of symmetry, so I'm going 2 to the left, and I'm putting my new point right there. Make sure that you're measuring the distance from the axis of symmetry, not the y-axis, because that'll screw your graph up. And then last thing I need to do, just connect my dots, to make a parabola. So 5 points for this question. You get 1 point for A, B, and C, and then 2 points for your word graph. Questions on 10. All right, question number 11. Again, we have another quadratic equation, but this time it's written in standard form. So standard forms, you have to find the vertex. To find the vertex, you've got to first start off and find the axis of symmetry. Well, I guess I skipped the first. Take that back. First thing we need to do is answer part A. Does your parabola open up or down? Again, that's always the first number, or A. So this one, since this is negative, this parabola will again open down because A is negative. Our axis of symmetry, if we're given standard form, we need to take x equals -b divided by 2 times A. This formula, again, is on your reference sheet in case you forget it. So opposite of B, so I want the opposite of 12 is -12 divided by 2 times A, which is -2. So -12 divided by -4 gives us +3. So my axis of symmetry is x equals 3. Remember, your axis of symmetry is the x value of your vertex. So we know that the x value of our vertex is 3. To find y, we're going to the original equation, and we're going to substitute all the x's with 3's. So this is exactly what I would type in my calculator. I would use those exact parentheses, and my calculator would tell me that equals 2. So my vertex is the ordered pair, 3, because 3 is what we plugged in for our vertex. The y value we were given is 2. The last thing we need to do is graph this so we know that our axis of symmetry is 3. So I'm going to draw in my dotted line. We're going to reflect over that in just a minute. And then I need to plot my vertex. So 3, 2 is right here. Your vertex should always be on your axis of symmetry. And then we get to make an XY table. 2 numbers to the left or 2 numbers to the right. of 3, so let's do 2, 1. If I plug in 2, again, I'm just going back into my calculator. I'm editing these two numbers right here, changing them to 2's, and I'm hitting equal again. I'm not retyping everything in my calculator. I'm doing it the easy way. So that change them to 2's, it gives me 0. If I change them to 1's, I get -6. So now I have 2 new points to plot, 2, 0, and 1, -6. And then I'm going to reflect those 2 points to the other side of my axis of symmetry. So 4, 0, and 5, -6. Last thing I need to do, connect all my points to make a parabola. This question is worth 7 points because it's more work than question 10. Because you've got to find your vertex instead of being given it. Questions on this one? So 2 graphing problems. The first one will be in vertex form. The second one will be in standard form, and you're going to go through this exact process with different numbers. All right. So Jason is jumping off a cliff while vacationing with some friends. His height is, as a function of time, could be modeled by this equation, where t is the time in seconds and h is the height in feet. Part A says, what is Jason's height after 3 seconds? So I'm giving you 3 seconds. Am I going to plug that in for h, or am I going to plug that in for t? T. I'm giving you the time in seconds. So I'm going to take all the t's out and I'm going to replace them with 3. So -16 times 3 squared plus 16 times 3 plus 672. Again, I highly suggest that you write this step out before you type it in your calculator, because I can give you 1 point for writing this down, even if you type it in your calculator incorrectly and get the wrong answer. So when I typed it in my calculator, I got 576 feet. So while I believe you can type all this in your calculator and get that answer, if you happen to do it incorrectly, I can still give you partial credit for that first line, even if your second line's wrong. So it's worth 2 points. I would still give you 1 point if you showed me what you typed in if it was correct. How long did it take Jason to reach his maximum height? The time it takes to reach the maximum height is just asking you for the x-coordinate of your vertex. So we're just trying to find the x-coordinate of our vertex. Since it's in standard form, x equals -b divided by 2a. So -b is -16. Divided by 2 times a, which is also -16. So -16 divided by -32. Common mistake here is to tell me that the answer is 2. Is not. So it's technically 1/2, but since I'm going to plug it back in using my calculator, I'm going to use 0.5. Yep, seconds. So Jason reaches his maximum height in 1/2 a second, which means when he jumps, he's only going up for 1/2 a second before he starts coming back down. To figure out the maximum height that Jason reached, we've got to take and figure out his height at 1/2 of a second. So we're going back to the original. Anytime we see second, we're plugging in 0.5. So -16 times 0.5 squared plus 16 times 0.5 plus 672. Again, my preference is that you show me what you're typing in your calculator. In the event that you would type it in incorrectly, I can still give you partial credit. So when I type all this in my calculator, I end up with a height of 676 feet. So Jason's maximum height is 676 feet. Questions on these three parts, they're all worth 2 points. So right there, 6 points, and we haven't even got to part D yet. Everybody okay with three parts before I move on? Okay. Moving to part D asks us, after how many seconds did Jason hit the water? If Jason's hitting the water, his height is going to be 0. So what I'm telling you to do for this part is take the height and plug in 0. So 0 equals negative 16t squared plus 16t plus 672. You get 1 point for writing that down for part D. You could, by all means, try to factor this the way it's written, but it would give you very, very, very large numbers. I'm telling you on this question and on the one on your test, you're going to divide by whatever number is sitting right here. I actually think it's also negative 16. So we're going to divide every single term by negative 16. I promise on your test, this is what's going to work. So 0 divided by negative 16 is 0. Negative 16t squared divided by negative 16 is just t squared, or 1t squared. If you wrote the 1 there, that's okay. Minus 1t minus 42. So 672 divided by negative 16 is negative 42. This gives you much smaller numbers to use to fill out your asterisks. So when I fill out my asterisks, A goes top left and top right, so that's where those two 1s came from. B goes in the bottom middle, so since we have a minus t, that's just a negative 1 in the bottom middle. And then the top middle, I took 1 times negative 42 to get negative 42. So when I fill out my two numbers, they have to multiply to give me negative 42, but add to give me negative 1. Yep. So negative 7 and positive 6. So my two factors are going to be these two fractions because there's 1s on top. I know that I can't reduce. So I'm going to go up here. So I have t minus 7 and t plus 6 equals 0. I have two factors being multiplied together and their product is 0, so one of them has to equal 0. When I set these both equal to 0, I get t equals 7 and t equals negative 6. Remember, we were calculating the time it takes Jason to hit the water. If I told you that it took Jason 7 seconds to reach the water, would you believe me? It is a long time. But if I told you it took Jason negative 6 seconds to hit the water, would you believe me? No, it's not possible for him to reach the water after negative 6 seconds. So we just have one answer, that your time equals 7 seconds. So Jason's hitting the water after 7 seconds. Questions on this one? Questions 13, 14, and 15 all deal with complex numbers. Again, complex numbers just have imaginary numbers in them. You've got to know that I squared equals negative 1. You've got to know this. So we're going to use that actually not until we get to question 15. Because when I look at question 13, I have a subtraction problem. So I want to distribute, that's like a negative 1 sitting out front that I want to distribute. So I'm going to leave the first set of parentheses 13 minus 3i When I distribute, -1 times 7 is -7. -1 times 6i is -6i. And then all I need to do is combine like terms. We just combine these like we would if they were x's. So 13 minus 7 is 6. So these got put together. And then these are going to get put together. So -3i and -6i is -9i or -9i. Again, it's customary to write the real number first, followed by the imaginary. So 6 minus 9i is the customary way to write this. Question 14 is actually easier than question 13 because this time it's addition between your two sets of parentheses. Since it's addition, all you need to do is combine like terms. So when I look here, 6 plus 8 is 14. Positive 5i and -7i give you -2i. Final answer. So those two are my favorite because they're pretty straightforward. The only thing you've got to watch for is that negative. When I look at question 15, now there's nothing written between my two sets of parentheses. When there's nothing written, it's got to be multiplication. So when you have two factors set equal, multiplied together, you're going to box them. So when I box them, one of them goes across the top, one of them goes across the side. So 7 minus 2i and 3 minus 4i. Make sure you bring those minus signs down. And then I'm going to multiply corresponding boxes. So 3 times 7 is 21. 3 times -2i is -6i. -4i times 7 is -28i. Be careful with this bottom right box. So -2i times -4i is 8i squared. But remember, this i squared gets replaced with -1. So -1 times 8 is actually -8. So the value for that box should be -8. Once we get here, all we've got to do is combine like terms. So 21 minus 8 is 13. -6i plus -28i is -34i. Final answer. So tricky thing there, you've got to remember that I squared equals that -1. All right, question 16 says the problem below is solved incorrectly. Describe the mistake and find the correct answer. My suggestion is on any of these problems that you take the original, don't look at what they did, solve it. Off to the side, go ahead and solve it. You know you've got to find the correct answer anyway. Don't try to tell me there's no mistake because there is. I'm not going to tell you there's a mistake, find it, and then there not be one. Inevitably, somebody will answer that every term. So we're going to go ahead and take that problem and we're going to box it together. So 5 plus 4i and 7 minus 2i. 7 times 5, 35 in the top left box. 4i times 7 is 28i. Negative 2i times 5 is negative 10i. And then your tricky box, that bottom right-hand box, negative 2i times 4i is negative 8i squared. Again, you've got to be mindful I squared equals negative 1. So negative 8 times negative 1 is actually positive 8 for that box. When I combine like terms here, 35 plus 8 is 43. 28i minus 10i is 18i. So that right there should be my correct answer. So this is my correct answer. I could actually go ahead and write that on my correct answer line. So 43 plus 18i. So I don't forget that. And then I've got to figure out what in the world did they do wrong. So when looking back at my answer compared to their answer, they both have 18 i's in them, but one of them has 27, or their work has 27 and mine has 43. So we've got to figure out what they did wrong to get 27 and not 43. So looking back through their work, their step number 1 should just be the first 4 terms that I put in my box. So looking at the first 4 terms, they've got their negative 8i squared, which we wrote over here to the side. So their step number 1 is just fine. Step number 2, they combined. The only thing that changed was they put these 2 terms together. Well, if I put those 2 terms together, you get 18i because we know that isn't our answer. For step number 3, they've went from negative 8i squared to negative 8. Is that correct? No, they didn't change the negative 8i squared to positive 8. So you could tell me in step 3, the negative 8 should be positive 8 because your negative 8i squared becomes negative 8 times negative 1, which is positive. So there's lots of different things you could write there. You could tell me they didn't replace I squared with negative 1. Something along some of those lines. So again, there's lots of answers you could have there, as long as you're telling me something's wrong when they went from negative 8i squared to negative 8. So between step 2 and step 3, I would say the error happened in step 3 because that's when they wrote something incorrectly. Questions on this one? So this one's actually worth 4 points. You get 2 points for telling me the mistake and 2 points for the correct answer. Question 17, what is the conjugate of 8 plus 5i? So the conjugate just means you're taking the sign in the middle and you're flipping it. So if it's positive, you're going to make it negative. If it's negative, you're going to make it positive. So the only thing I'm allowed to change is this sign right here. I'm going to change it to a minus, and there's my conjugate. So letter D. Worth 2 points on your test. Really no work required. Just make sure that you're only changing the sign in the middle. You can't change the sign on the 8. And then question 18, conveniently, I've just asked you how to find a conjugate. And then question 18, you've got to use a conjugate to solve your problem. So Question 18, when I ask you to simplify, that just means, hey, get rid of all the imaginary numbers from your denominator. If I'm getting rid of the imaginary numbers from the denominator, I have to multiply by the conjugate of the denominator. So looking at the denominator, I'm changing the sign in the middle. So 8 minus 6i is what I'm going to multiply both the top and the bottom. So really, this is just two box problems. You're going to do a box problem for the top, and you're going to do a box problem. Oh, that was very small. For the bottom. So we're going to do one for the numerator, one for the denominator. So I'm going to do the numerator first, and then the denominator. So 5 plus I and 8 minus 6i. Multiply corresponding boxes. So the top left box, I'm going to multiply 8 times 5. Top right box, I times 8, which is 8i. 5 times negative 6i for the bottom, oops. For the bottom left box, and then the bottom right box is my tricky box. I'm going to take negative 6i times I, which is negative 6i squared. We want to replace that I squared with negative 1, so negative 1 times negative 6 is positive 6. Yeah, that's fine. So you just wrote all, you should just have all 4 terms written out. Yeah, that's fine. That's the way I was taught in school. So for my answer, I know the numerator is going to be 40 plus 6, which is 46. Negative 30i plus 8i, which is negative 22i. So there's the numerator of my answer. Then I'm going to multiply my denominator just like we did the numerator, except this is my 8 plus 6i and my 8 minus 6i. Again, multiply your corresponding boxes. 8 times 8 is 64. 6i times 8 is 48i. Negative 6i times 8 is negative 48i. And then 6i times negative 6i is negative 36i squared. Oops, that squared was huge. Remember, I squared equals negative 1, so really this is negative 36 times negative 1, which is positive 36 for that box. When I go to combine like terms, 64 plus 36 gives me 100 for the denominator. And then negative 48i plus 48i is going to cancel. So a positive 48i and a negative 48i just cancel. When I look at my answer, 46 minus 22i all over 100, all of those numbers are even, so I'm going to have to reduce. Just divide every term by 2. So actually, my final answer, I would write 23 minus 11i divided by 50. Questions on this one? So this one, you actually get 1 point for your numerator, 1 point for your denominator, and then 1 point for reducing your answer. So 3-point question. Question 19, solve the following systems of equations algebraically. So I've given you a quadratic equation and a linear equation. Quadratic one's on top because it's got x squared in it. The linear one just has x. We know that both of these equations are already set equal to y, so this box must equal this box. If they both equal y, they have to equal each other. So really, I'm telling you that x squared plus 5x plus 2 has to equal 3x plus 5. And you could have written that the other way. You could have written the 3x plus 5 first. I tend to always write the quadratic on the left. So 1 point for telling me that these two are equal to each other. This is a 4-point question. For the next part, you're going to get 0 on one side, so subtract 3x and subtract 5, so minus 3x minus 5. That gives me x squared plus 2x minus 3. So that gives me a quadratic in which I need to factor. So a is 1, so I'm putting 1 in the top left, top right, 2 in the bottom middle, and 1 times negative 3 in the top middle, which is negative 3. Two numbers that multiply to give me negative 3 and add to give me 2, 3 and negative 1. So that gives me factors x plus 3 and x minus 1, which really tells me that x plus 3 equals 0 and x minus 1 equals 0. So my answers, or my x's of my answers, are going to be negative 3 and positive 1. There's another point. But remember, this is a 4-point problem, and we've only got 2 of the 4 points. When we have a system of equations, we always have ordered pairs. Even if this is a parabola and a line, they're still going to cross at ordered pairs. So to figure out the ordered pair, I know the x value is negative 3, but I've got to find the y. I know for the second one, the x value is 1, but I've still got to find that y value. There's an easy way to figure out the y value, and there's a harder way to find out the y value. The easy way is indeed plugging into the second equation here for x. So if I know x is negative 3, I'm going to take 3 times negative 3 plus 5. Well, 3 times negative 3 is negative 9, plus 5 is negative 4. So this ordered pair would be negative 3, negative 4, final answer. For the second one, I'm going to take and I'm going to plug in 1. Again, I'm going back to that linear equation because it's easier. 1 times 3 is 3, plus 5 is 8. And there's my second answer. So make sure on this question, if you end up with 2 x values, you should have 2 ordered pairs as your answers. Don't stop when you find the x's because there's your last 2 points for this question. Questions on this question? All right. Last but not least. Remember how I told you you wouldn't have to do this question ever again? This question on your actual test is extra credit. You can earn up to 5 points for doing it all correctly. If you do part of it, I'll give you partial extra credit. If you do the first 2 steps correctly and then you don't know where to go for the 3rd step, that's fine. I'll still give you partial points. So, you want me to work through it? We've got time. Okay. All right. So looking at this question, all 3 equations have all 3 variables. So it's not like the last test where you were given one that was missing one and it worked out really easily. So here you want to pick what variable you want to eliminate first. A, I would definitely go with A. So A has a 1, a negative 2, and a 1. So I would just eliminate A from all 3 because B's got 1, 4, 2, and C has 4, 1, and 5. So C would definitely be the hardest to eliminate, but I would go with A. So you're going to pick 2 equations. I would just pick these first 2. If I want to eliminate A from the first 2 equations, I've got to take the first equation and multiply the whole thing by 2. So I'm going to go over here to the left, and I'm going to multiply the whole first equation by 2. So 2A plus 2B minus 8C equals negative 54. So that's the whole first equation multiplied by 2. 2 times a is 2a, 2 times b is 2b, 2 times negative 4c is negative 8c, and then 2 times negative 27 is negative 54. Thankfully, the second equation already has negative 2a to begin with, so we're just copying it down. So we're just bringing this equation over here. So top equation we multiplied by 2, the second equation we just brought over, and now we can eliminate a from these two equations. So to eliminate a, we're going to add straight down. When I add straight down, the 2a and the negative 2a cancel. 2b and 4b give me 6b. Negative 8c and negative 1c give me negative 9c, and that's going to equal negative 57. Now we're going to repeat this same process with two different equations. So I would do the same process, except this time I would do the bottom two equations. And again, I'm going to multiply the whole bottom row by 2. So the middle equation is going to stay negative 2a plus 4b minus c equals negative 3. So that equation is staying the same. And then that bottom equation, I'm going to work my way through and multiply everything by 2. So 2 times a is 2a. 2 times 2b is 4b. 2 times 5c is 10c. Equals 2 times 16, 32. Now I have opposite coefficients. I've got a negative 2a and a positive 2a. So since I have worked this out, I'm going to go ahead and add straight down. When I add straight down, the negative 2a and the positive 2a cancel. 4b plus 4b is 8b. Negative c and 10c give me 9c. And negative 3 plus 32 is 29. So far I've worked myself to 2 points. Again, if you get stuck and don't know where to go from here, you're still going to get your 2 points. It's not an all or nothing. So now I'm going to take these two equations and I'm going to bring them down. So actually, if I'm really lazy, copy this. Oh, I copied them. All right, so I copied those two equations down. What do you notice about these two equations? Aha, so C, one of the C's is a negative 9, the other one's a positive 9. This is already set up for you to eliminate. You do not have to multiply by anything. So we just brought those two equations down and then we're going to add them together. When we add them together, 6b plus 8b is 14b. The 9c and the negative 9c cancel. And then negative 57 plus 29 is negative 28. So now we have 14b equals negative 28. You're going to divide both sides by 14 to get b equals negative 2. There's another point, but this time we found something. So we found b. Once you find b, you get to go back to one of these two equations. So you're going back to one of these two, and you're going to plug in b to find c. Doesn't matter which one you plug into. I would probably plug into the one on the right because it's positive. So 8 times negative 2 plus 9c equals 29. So negative 16 plus 9c. Add 16 to both sides. Divide by 9. And c equals 5. Oh. So there's another point. And the last thing I need to do is take B and C and plug it into one of the originals. I would just stick with the first one because A plus B minus 4C doesn't look too terrible. So last step, A plus B minus 4C equals negative 27. And we're just going to plug in B and C. So let's see, we don't know A plus negative 2 minus 4 times 5 equals negative 27. Let's see, negative 4 times 5 is negative 20, minus 2 is negative 22. So A minus 22 equals negative 27. Add 22 to both sides, and A equals negative 5. I did mine in 2. So here's negative 20 minus 2. Gives me that negative 1. So then I have to write my final answer. My final answer in this case, since I have 3 variables, is going to be an ordered triple. So A comma B comma C, so negative 5, negative 2, 5 is my final answer. Again, this is worth extra credit on your test, so if this overwhelms you, don't worry about it. Study the other 19 questions. Questions or concerns of anything you want to go back over or see again?